Right. Hello, everyone. I had some requests on making a video going through calculating the circumcenter of a triangle given just 3 points, given the coordinates of the vertices. So I have the problem worked out and I have it color coded. I'm going to kind of walk you through the methodology and sort of the algorithmic approach of solving a question like this. So I was given these coordinates. By given, I mean I made them up. And I intentionally made them really so that my circumcenters would be pretty nasty. Okay, so I label my points A, B, C, and then I roughly graph them. By roughly graph them, I very much so mean roughly graph them. Now they should be their position with respect to one another should be correct. Like you wouldn't want to have point C in quadrant one. Okay, but just a general outline. Okay, the first thing I did was I calculated my slopes right here where can my mouse hover? There it is, where my mouse is hovering. Calculated my slopes. And then since this circumcenter is the point of concurrency where the perpendicular segment bisectors meet, then I found the perpendicular slope. And notice how I'm labeling it and working across from left to right. Okay, so I'm keeping it all consistent. And then I found the midpoints of each line segment. So I found the midpoint of AB, midpoint of BC, and the midpoint of AC. So slope for formula, or excuse me, formula for slope, which is this part, which I'm hovering over, y2 minus y1 over x2 minus x1, or you could also correctly state y1 minus y2 over x1 minus x2. And then to find the perpendicular slope, you're just taking the opposite reciprocal of the slope here. And then, of course, our midpoint formula, taking the average of the x values, or x1, x1 plus x2 divided by 2, and then, of course, averaging the y values, y1 plus y2 all over 2. So those are just computational things, right? Those are things where when you're working with fractions, always check it with a calculator, execute with precision. Okay, so then here's where I started color coding. So I just sort of arbitrarily chose the perpendicular bisector of AB and CB. And to calculate the equation of this line in pink, I needed my point slope form, so y minus y1 equals m quantity x minus x1. So all I'm doing here is just plugging in my values in pink. So there's my perpendicular slope. So again, I need the slope of the line that is perpendicular to CB and passes through its midpoint. So that's why I chose the midpoint and the perpendicular slope. Then this is just simplifying, and I get y equals negative 7/13 x minus 16/3. Okay, then from here, I went and calculated the equation of this line in blue. Okay, of this line in blue, and maybe I should also on here. So we'll get our blue. So I am using midpoint of, what is this, AB in this case. So I used the midpoint here and the perpendicular slope negative 3/2. Okay, and again, just simplified it down to set it equal to y. Now I need to solve a system of these two equations to find where they intersect, right? I'm trying to find this point of intersection. So if I have the equation of the two lines, then I just need to set those equations equal to one another. And then I get this business here in purple. So this is where I'm solving my system. As you can see, I set the pinkish equation equal to the bluish equation. And I solved to get x equals 467 over 50. Now I know fractions, especially something like this, can be a little intimidating, but just trust the math, trust the process, and it'll all work out fine. So I solved for x, and even though this is kind of a nasty number, I can plug that back in. Now, what did I choose here? I chose the equation in blue, but you very well could have also chosen this one. Okay. And I plug it back in to get my y value. So then the the circumcenter should be my x-coordinate 467 over 50, comma, negative 13 over 50. And you can go to, if you want to like double check your work, like what I think would be good or fun is just pick like 3 random points that, of course, obviously, form a triangle. Don't have them all be trilinear. Okay. Uh, and just work through the problem. And then there's a lot of like Circumcenter, OrthoCenter calculators online, and just check your work. And indeed, excuse me, this is our Circumcenter. I checked it online. Okay. I have it in fraction form. I love fractions, but if you convert it to a decimal, lines up as well. So anyway, I just wanted to make kind of a video going through the again, sort of the general process to take all of the computational stuff that just sort of requires precision. I will say this is not the cleanest work. I was a little limited by the computer, and but I wanted to like color code it, so hopefully it makes a bit more sense like as I'm talking through it and referring to the colors. So anyway, I hope you enjoyed this video and have a good day. Thanks. Bye.